They look at the species that's most likely to go extinct and they spend most of their money on those species. People then thought, that's a bit tricky, maybe the Sumatran tiger is really expensive and while we're saving that we could have saved 20 plant species.
Scientists now believe the rate of extinction is more than 100 times normal, meaning species are becoming extinct more quickly than new ones can evolve. With limited funding available for conservation efforts, deciding where and how to spend it becomes a critical matter. At the 2013 SIAM Annual Meeting, Professor Hugh Possingham discussed how mathematics can be applied to help optimize the return on investment from those decisions.
In conservation, people are obviously trying to save nature, but if you say save nature, what does that really mean? And so they've got money to spend on ecosystems and species and interventions in ecosystems. But until you can turn it into a mathematical problem, of course, their allocation of money to different activities is very much based on intuition and whim.
A common conservation strategy is to allocate significant resources to save a single highly endangered species. However, as Possingham noted, a more sound investment would be allocating those dollars to preserve multiple species or on conservation efforts with a high probability of success.
The general notion of return on investment thinking is pretty common. People all over the world use it every day. As I often say, there's 1 billion people who shop every day and they're thinking about expected benefit of buying this product divided by the cost of that product, and the higher that number, benefit over cost, the happier they are. Somewhere in the world today there will be a government agency or a non-government organisation taking a whole heap of criteria, not stating a problem, turning those criteria into scores out of 10, adding them up and spending hundreds of millions of dollars of your money. This is how bad this field is.
Possingham stressed the importance of developing sound mathematical tools for use in ROI-based decision-making, highlighting how simplified scoring and ranking systems are inadequate.
You wouldn't go into a supermarket and look at 2 kinds of cereal or 2 kinds of rice and look at the volume and the quality and the price, turn them into numbers and add them up. You would divide by price because that's cost effectiveness. So there are logical ways of combining numbers. Unfortunately, many of these agencies, for them, the most logical thing to do is just to add things up.
When it comes to influencing policy decisions, Possingham commented on the benefit of researchers being able to communicate their work in easy-to-understand terms.
Once you throw algebra at most policy and conservation ecologists, you've already lost them. You may as well be putting up Chinese symbols. So you've got to turn it into very, very simple examples and into pictures as well.